Hey, Math 10. We're going to be doing another video right here. So, some notes. You can download these notes in our Microsoft Teams so you can follow along. And so, last time we talked about surface area, and this week we're going to be talking about volume. So, the first one right here, we have some notes right here. So, first off, what is volume? The volume of a solid is a measure of how much, oops, we lost our thing right there, is a measure of how much space it occupies. The volume is measured in either liters or something that is cubic. And what that cubic means to the power of 3. So something to the power of 3. So usually a length to the power of 3. And there's two different types of ways that we can measure volume. We have the metric system to measure volume, which is our system international or international systems units. And then we have the imperial, which is mainly our Americans down south, and they usually use the imperial system for this. So first off, let's talk about metric. Very common things that we measure things in are liters and things that are related to liters, like milliliters. Okay, now that cubic thing that I mentioned is that we can just do a distance to the power of 3. So cubic meter, cubic centimeter, cubic millimeter. So for example, a cubic meter would be 1 meter. Okay, so it would be 1 meter. We know we should roughly have an idea of how long 1 meter is. One big step or 1 meter stick. Okay, so a cubic meter is 1 meter by 1 meter. Okay, by 1 more meter. So it makes a cube or a box. Now, if you can't remember how big a meter is, most people in class are around 1.5 meters tall. So this is how tall that box would look next to you, something like that. Okay, so it's a pretty big kind of size right there. Now the next thing is that we should know what a liter is, and a milliliter is there's 1,000 milliliters in 1 liter. Now something that we need to memorize that a lot of people don't quite know is that 1 milliliter is equal to 1 cubic centimeter. So centimeter cubed. That's an important thing for us to kind of memorize. Now, many people in class ride dirt bikes and all that kind of stuff, and a lot of people have dirt bikes that are 250 cc's. Now, I don't know why, to be honest, but cc stands for cubic centimeter. Okay, and that is just the volume. That is the volume that the cylinder or cylinders displace. Okay, so that's the volume of the essentially the engine and how much space that the cylinder can have inside of it. Now, if that's for dirt bikes and quads and all that kind of stuff. Usually smaller engines, we'll talk about cc's, cubic centimeters. If you were driving a truck or a car, you might be using something different like liters. And if you're doing, so we'll say that truck has a 5-liter engine, or that car is a 2.4-liter engine. Okay, it's just because we don't want to say uh, essentially we don't want to say that's a 5,000 cc uh, engine, right? Like it's just so we kind of use the units that are a little bit more appropriate. In the United States, they don't use liters or cc's as often, so often they'll measure their cars in cubic centimeters, and so they'll say, you know, 350 cubic, or sorry, not cubic centimeters, cubic inches, and then that's how they'll measure their sizes of their engines. So imperial system, we still they kind of measure in quarts and gallons and fluid ounces, cubic inches, cubic feet, and cubic yards. We still, since we're so closely related to the states, we still use a lot of the imperial system. For example, we often use cubic yards when we are discussing if we're buying like gravel, for example, or sand or topsoil, and you have to load it in the back of your truck. You'll have to say something like, "Oh, you're picking up 2 or 3 cubic yards of soil for your truck," and yeah, okay. So now that we kind of understand what volume is, how it's measured, we're going to do some problems with that right here. So first question right here, it says Joe has a bulk container that holds 2,000 cubic inches of dog biscuits. He plans to sell the dog biscuits in small boxes that measure 5 quotation marks by 8 or by 6 quotation marks. Now remember, this double quotation marks right here, that means 5 inches by 8 inches and by 6 inches. So Joe has a bulk container that holds 2,000 cubic inches of dog biscuits. Okay, he plans to sell these dog biscuits. So first off, what it's saying is that he has a big box, something like this. We don't actually know the dimensions of the box. We don't know the length of this side right here or any of that kind of stuff. But we do know that the whole box is 2,000 inches cubed. Now we have these smaller boxes like this, and he wants to put these inside of this big box, and he wants to know how many of these small boxes can he fit inside this big box. So first off, we're going to find the volume of this small box. So if we go to our formulas, so if we have our formula sheet right here, we want to find out the volume of the big box. So here's a box right here. It's called a rectangular prism. And it says volume equals area of the base times the height. Now, the area of the base is just going to be the width times the length, and the height is this one right here. So you can just memorize this. If you want to find the volume of any types of box, it's just, rather than saying area of base times height, you can just say length times width times height. So let's go back to here. So volume is going to equal length times width times height. And that's true for only for boxes. That's the formula for volume for boxes. So first we're going to find the volume of the small box. So volume of the small box. We're going to keep it in inches. It's going to be length times width times height. So it's going to be 5 times 8 times 6. So the volume of the small box equals 5 times 8 times 6. So you can use a calculator. And we get 240. And since this is in inches, we're going to write inches as well. Since we went inch times inch times inch, that becomes inches cubed. So the volume of the box is 240. Now, we need to figure out how many of these things can fit inside that big box. So what we're going to do is we're going to go 2,000 cubic inches, and we're going to figure out how many of these can go into this box. So we're going to divide by 240 inches cubed. I forgot to write a cube there. So we're going to go 2,000 divided by 240 equals, and I get 8.333, like that. Okay. Now, this is where it gets a little bit tricky when you have a decimal that's involved. Okay, so what it means is that what we can do is with 8.333 is that this number, we can fit 8 boxes into this larger box right here. So in other words, 8 of these can fit inside of that. Okay, and we can fit a third of a box, or 0.333 of a box. So if we were to cut this box into 3 pieces, one of those little pieces can fit in there. Now we're not going to cut this little box into 3 little pieces, so we're just going to have a little bit of extra room in there. So what we would say is that 8 boxes can fit in there. Okay, and that would be the answer. So it would be a requirement that you round this number down. Okay, and the number will always round down. So if it said 8.99 boxes can fit in there, well, you'll have to say, well, it's going to be 8. I know some people want to round it up to 9, but you can't do it. Okay, it'd be too much. Okay, next one right here. Lisa wants to store bricks in a wooden crate. The bricks measure, we have these things again right here. So those are inches. And the wooden crate measures, now we have the single quotation. That means feet. Okay, so this wooden crate is going to be 3 feet by 4 feet by 2.5 feet. So now what we're going to do right here is that we can't start doing the same thing as the previous question. We need to have all the same units. So since this one is in feet and this one is in inches, they have to be the same unit. So what I'm going to do is I'm going to convert all of this crate stuff into inches. So how we do that is times all these numbers by 12. So I'm going to do that right here. So I'm going to take 4 feet times by 12, and that's going to be 48 inches. 3 feet times by 12 is now going to be 36 inches. And then 2.5 feet times by 12 equals 30 inches. So now I'm going to find the volume of this box. So big box, or say big volume, okay, is going to be length times width times height. Okay, so we're going to do that into our calculator. We're going to go 48 times 36 times 30 equals, and we get 51840 inches cubed. So we get 51,840 cubic inches. Now, one brick is 2 inches by 4 inches by 8 inches. So the volume of this, so I'm going to say small volume, 2 times 4 times 8, and that's going to be 64. Inches cubed. So how many of these bricks can fit into this big crate right here? Well, we're going to do the exact same thing and figure out and divide these. So I'm going to go 51840 over 64. Oops, inches cubed. So 51840 divided by 64 equals, and we get 810 bricks. That's a lot. Okay, so 810 bricks can fit inside of this crate. So when you do the divide thing right here, what you're saying is how many 64 cubic inches can fit inside of this 51,000 cubic inches. And so the number is 810 exactly. And so that's our answer. 810 bricks can fit inside there. Okay. Next one right here. What is the volume of this object right here? So the next thing is that we are going to use our data booklet. So we're going to pull that thing back up. We're going to find we had a cylinder right there, and it says the formula for a cylinder is volume equals area of base times height. Now, what's the area of the base? Well, we look over to the surface area right here, because that's the area, and it says area of base, which is pi r squared. And so it's going to be pi r squared times height. So we're going to go back to this thing. And so we're going to say volume equals pi r squared. So that's area of base times the height, h. Okay, so we're going to plug in some numbers. Our volume equals 3.14. R stands for the radius. This is the diameter. This is the diameter right here. So in other words, 10 feet is the radius. Okay, so it's going to be times 10 squared, because that's the radius. We don't want the diameter. And then we're going to multiply that by the height of this. And I know this seems like, since this thing is going sideways, on the picture right here, a cylinder, this length of it, this part right that's going up and down right here, that's the height. So even though our cylinder is on its side, 38 is still considered the height. So we have volume equals, and we're going to go multiply all these things together. So do the exponents first. So 10 squared, which is 100, times 38 times 3.14 equals, and we get. Now, since all these units in this question are feet, okay, our answer is going to be feet, but since we're dealing with volume, cubed. Okay, and that is our answer right here. Next question right now. What is the volume of this object? Now, this object kind of looks like an ice cream cone. And what this object is, it's two objects. So the first object right here is a half a sphere, half a ball. So we have two objects. The first one is half a ball. Or to be a little bit more kind of thing, it's not a ball, it's a sphere. Okay. And even if we want to be even more technical, it's not half a sphere. Well, it is half a sphere, but we can say, instead of saying half a sphere, we can call it hemisphere. Okay, so just half a ball, or hemisphere. The other object that we are dealing with right here is a cone. So we have two objects right here. So we don't have like this ice cream cone shape in our data booklet, right? But we do have a sphere and we do have a cone. We don't have those things combined. So first off, we're going to look at the sphere. So it says volume equals 4/3 pi r cubed. So we're going to go back here and we're going to say, so a circle, or a sphere, sorry, is volume equals 4/3 pi r cubed. Now, this is the important thing that we have to be able to recognize, is that we are not dealing with a full sphere. We're dealing with half a sphere. So this all needs to be divided by 2. we need to half it. So divide by 2 because it's a hemisphere. It's not a full sphere. So that's the this is going to be the formula that we're going to use to find out what is the volume of just this part right here. Okay. Now we need to find the volume of the cone. So we're going to look up our formula again, and our volume of a cone equals 1 over 3 times area of base times height. So again, area of base, we're going to look that up right here, and it says area of base equals pi r squared. So it's going to be 1/3, or 1 over 3 times pi r squared times height. So we're going to copy that down over here and say volume equals 1 over 3 1 over 3 times pi r squared times height. Okay, and that is going to be the rest. So we have to do this kind of calculation in 2 parts right here. Okay, so let's do this one first. So we're going to go volume equals 4 over 3 times 3.14 times r. Now, if we're looking at this 10 centimeters right here, that is going to be the diameter. Okay, so again, half of the diameter is the radius, so that's going to be 5. That's going to be cubed. So we have to do all of that first, and then after we have done all this top stuff first, we're going to take all of that and then divide by 2 because we only want half of it. So I'm just going to show you kind of how to do it. So first off, I have to do 5 cubed. So 5 cubed. Okay. Now 5 times 5 times 5 is 125. So then I'm going to go times by our pi, so 3.14, times by 3.14. And you can use the pi button too on your calculator. Okay. And then I'm going to go times 4 over 3. So times 4 divided by 3. Okay. And so I get this number right here, 523.3333 on forever, divided by, and that still needs to be divided by 2. So then I'm going to divide that by 2, and I get 261.666 going on forever. Okay. And so that's going to be centimeters cubed. Now this is just the volume of the half sphere. Now I need to find the volume of the cone. So again, I'm going to take this formula right here. We're going to go volume equals 1 over 3 times 3.14 times the radius. Again, here is the diameter, so half of that is the radius, so it's going to be times 5 squared times the height. Now here is this very, very tricky part. This number right here, this number is called the slant height. And if you're unsure about that, you can go back to this thing right here, and it'll show you the slant height is right there. We do not want the slant height. The slant height is used for finding out the area. We need to find out the volume. So we need to use the true height. So that is the true height of the center of the circle to the very peak of the cone. Okay? So this number we are not going to be using. We're not going to be using that 11 centimeters right here today. Now, this is the kind of the tricky thing right here. This is 5 centimeters. That's the radius. Okay, from the center of the circle to the outside is 5 centimeters. The center of the sphere to the outside is 5 centimeters. Now, also that means this length right here is also 5 centimeters. So if this total is 10, and that means right here is 5, okay? So this is 5 right here. And that means the height from here to the end right here, that means this is 10 centimeters. So the height is actually 10 centimeters. So I'm going to write down for the height is 10 centimeters. This one's a tricky question because you don't need that 11 number to find out the volume. That's for surface area. If we're asking surface area, you would definitely need that number. Anyways, so now we have all these numbers here. So now we're going to plug this into our calculator, and we're going to go our exponents first. So 5 squared, so 25 times all those other numbers. So times 10 times 3.14. Okay. And then divide by 3. Sorry, 1 second. This is just pure coincidence, but we get the exact same volume as the one above. So it is also 261.66. Oops. Row 0 should be 6 centimeters cubed. I did not design the question to have those two sides or two parts to be exactly the same, but that's just the way it works out. So just going to make sure, check my calculations. And 261.666, and then yeah, they just work out to be exactly the same. This is coincidence that these two numbers are exactly the same. So I don't want you to think that in the future they're always going to be exactly the same. So anyways, to find out the total volume of all these kinds of things, we need to add this number right here to this number right here. And what we get is we get our total volume of this complex object equals 523.33. And since it's all measured in centimeters, it'll be centimeters cubed. Now, if you want to be super technical, since you know that 1 cubic centimeter is equal to 1 milliliter, you could write technically 523.33 milliliters as well. So both would be an acceptable answer. Anyways, once you have done this, you feel comfortable understanding this as your answer and how to do all these kinds of things. I'd like you to attempt the volume quiz that will be posted later today. And if you have any questions, if you don't understand this, or if you have questions, message me before you write the quiz so that I can help you through it. And hopefully we'll get it done. Okay, good luck.